Hello, good morning, students. So today we will see one more experiment with respect to geotechnical engineering. So I'm sharing the screen. I hope it is visible. In the geotechnical engineering lab, we need to perform certain experiments. So the syllabus of the course learning objective includes wait. So the course learning objective includes to carry out laboratory tests and to identify soil as per IS codal provision, to perform laboratory tests to determine index property of soil, to perform tests to determine shear strength and consolidation characteristic of soil. Next, field identification of soil, specific gravity test, pycnometer and density bottle method, water content determination by oven drying method and pycnometer method, rapid moisture meter method. In the grain size analysis, we need to carry out CO analysis, hydrometer analysis, in situ density test, core cutter methods and replacement method, consistency limits, liquid limit test by Casagrande and confrontation method, plastic limit test, shrinkage limit test. Next, standard compaction test, light and heavy compaction, coefficient of permeability test, constant head test, variable head test. In the shear strength test, we need to do unconfined compression test, direct shear test, triaxial shear test. Next is unconfined undrained test only. So the consolidation test includes to determine pre-consolidation pressure only, half an hour per loading test, laboratory well test, demonstration of swell pressure test, standard penetration test, and boring equipment. So the textbooks used are PC Purma, Soil Mechanics and Foundation Engineering, Soil Testing for Engineers. Next, the reference book includes Head KH Manual of Soil Laboratory. Next, Bolts. So what are the course outcomes? After successful completion of the course, the student will be able to draw the particle size distribution curve and to find the particle size, to find the maximum dry density and optimum content, to find the CBR of the soil, to find the SBC of soil, to find the consistency limits of soil. So what are the things the student should do? They should bring the observation notebooks, lab manuals, and other necessary things for the class. Use tools for mixing concrete and water. Check the instruments for proper working condition while taking and returning the same. Thoroughly clean your laboratory workspace at the end of laboratory session. Maintain silence and clean environment in the don't. Do not operate the machines without the permission of the staff. Do not put hands or head while equipment is in running condition. Do not fix or remove the test specimen while the main is switched on. Do not spill the concrete and aggregates on the floor. So what are the list of experiments? Determination of specific gravity of soil solids by pycnometer method. Next, determination of specific gravity of soils by density bottle method. Next, density of water content of soil by oven drying method. Determination of water content of soil by pycnometer method. Determination of in-situ density by core cutter method. Determination of in-situ density by sand replacement method. Next, determination of particles say distribution by CO analysis. Determination of liquid limit of soil by Casagrande apparatus. Determination of plastic limit of soil. Determination of shrinkage limit of soil. Determination of maximum dry density and optimum moisture content by standard water compaction. Demonstration of coefficient of permeability by Constant head method, determination of coefficient by variable method. Next, determination of liquid limit of soil by one penetration method. Next, demonstration of shear parameters by direct shear test. Demonstration of unqualified surface testing. Demonstration of wind shear test. Demonstration of soil pressure test. Standard penetration test. So the first experiment is determination of specific gravity of soil solids by pycnometer method. So the first experiment is specific gravity by pycnometer method. Aim to determine the specific gravity of soil solids by pycnometer bottle method. So it includes specific gravity is the ratio of mass of unit volume of solid at a stated temperature to the mass of same volume of gas-free distilled water at a stated temperature. So how we are defining specific gravity? It is defined as specific gravity is the ratio of mass of unit volume of soil at a stated temperature to the mass of same volume of gas-free distilled water at a stated temperature. So what is the specification? This test is specified in IS 2720 Part 4 1985. A soil specific gravity largely depends on the density of the minerals making up the individual soil particles. However, as a general guide, some typical values for specific soil types are as follows. The specific gravity of the solid substance of a most organic soil varies from 2.6 and 2.8. Tropical iron-rich laterite as well as some laterite soils usually have a specific gravity of between 2.7 and 3, but could be higher. The sand particles composed of quartz have a specific gravity ranging from 2.65 to 2.67, whereas inorganic clays generally range from 2.7 to 2.8. Soils with large amount of organic matter or porous particles such as diatomaceous earth have specific gravity below 2.6. Some range as low as 2. So how we define specific gravity of soil? Specific gravity of soil is nothing but ratio of mass of soil in water to the mass of same soil in air. So which is code is used for determining specific gravity IS 2720 Part 4 1985. So we need to remember the specific gravity of standard soil such as specific gravity of inorganic soil is between 2.6 and 2.8, whereas tropical iron rich laterite soils have a specific gravity from 2.71 and 3, whereas sand particles composed of quartz have a specific gravity ranging from 2.65 to 2.67, whereas your inorganic clays specific gravity range from 2.7 to 2.8, whereas soils with large amount of organic matter has a specific gravity below 2.6 and even below 2. So what are the equipments required? First is pycnometer about 1 liter capacity. First, what you need? Pycnometer hose capacity is 1 liter. Next, balance accurate to 1 gram. Next, what you require? Balance accurate to 1 gram. Next, glass rod. De-aired distilled water. Next, specific gravity of soil solids is defined as weight of soil solids to the weight of specific gravity of soil solids is defined as weight of soil solids to the weight of equal volume of water. In effect, it tells how much heavier or lighter the material is than water. So, what you come to know from specific gravity value, we come to know how much heavier or lighter the material is than water. Comparison with water you can do. The test method covers the determination of specific gravity of soil solid that passes through 4.75 mm sieve. So, you can even test the method to determine the specific gravity of soil solids that can pass through 4.75 mm sieve. The equation for specific gravity G is W2 minus W1 divided by W2 minus W1 minus of W3 minus W4. So which equation is used for determining specific gravity? W2 minus W1 divided by W2 minus W1 minus of W3 minus W4. So using this equation, you can calculate the specific gravity of soil solids. This method is recommended for both coarse as well as fine grained soil. Precautions. So, what are the precautions you need to take during this test? Soil grains whose specific gravity is to be determined should be completely dry. जो सॉइल ग्रेन्स हैं जिसकी स्पेसिफिक ग्रेविटी आपको डिटरमाइन करना है वो completely ड्राई रहना. If on drying soil lumps are formed, they are found to be broken to its original size. अगर फिर भी ड्राइंग के बाद भी लम्प्स फॉर्म हुए, they should be broken to its in original size. Inaccurate in weighing and failure to complete eliminate the entrapped air are the main source of error. Both should be avoided. While cleaning the glass jar, while cleaning the glass jar, please be careful as there may be glass grains projecting out directly at the screen. Make sure you handle the glass jar and conical cap without falling on your legs or float. Hence, handle the equipment with care. Next procedure, clean and dry the pycnometer and weigh it along with conical cap that will be W1 gram. Select about 300 gram of dry soil free of clots and put the same into the pycnometer. Weigh it as W2 in gram with cap and washer. The first is clean and dry the pycnometer and weigh it along with conical cap that will be W1 gram. So how you are determining W1? Weight of empty pycnometer with cap is W1 gram. Next, select about 300 gram of dry soil free of clots and put the same into the pycnometer. Weigh it that will be W2 gram with cap and washer. After that, what you have to do? 300 gram of soil you have to take. You have to place this soil in the dry soil which is free from clot into the pycnometer, and again you have to weigh it. That will be W2 gram. Next, fill the pycnometer with de-aid water up to half of its height and stir it with mixed water. Add more water to seal. Feed the screw cap and fill the pycnometer flush with the hole in the conical cap and take the weight W3 gram. So W3 gram is weight of pycnometer with half filled soil and half filled water. That will be W3. Remove the contents from the pycnometer. After that, what you have to do, you have to completely remove the contents from the pycnometer and clean it thoroughly and fill it again with the distilled water. That will be W4 gram. So once again, I'm telling you, just listen it. What is W1, W2, W3, and W4? First, W1 is weight of empty pycnometer with conical cap. Next, what you have to do, you have to take 300 grams dried soil sample, which is free from clots, and you have to again weigh it. That will be W2 gram. After that, you have to add distilled water such that the water is half filled and half is your soil. Again, weigh it along with the lid. That will be W3. Now, completely remove all the sinks, fill the power thermometer with only water. Again, weigh that will be W4. So here, what you can say, specific gravity is given by the formula W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So repeat the process for additional test. Pre-viva questions. Why we need to compute the specific gravity of soil? The specific gravity of soil is needed in order to compare how much heavier or lighter the soil is with respect to water. What is the unit of specific gravity? There is no unit for specific gravity, it is unitless. What is specific gravity of water? 1. Explain the steps required to determine specific gravity of soil by pycnometer method. Just now I told you, I'm just once again repeating it, you listen it carefully. First, what you have to do, you have to take a pycnometer with the lid and weigh it. That will be W1 gram. After that, you have to take 300 gram of dry sample, which is free from clots, and add this to the pycnometer and weigh it along with the lid. That will be typically 2 gram. Now you have to fill the water up to the half of the pycnometer. Remaining should be the soil. That again you weigh it with lid, that will be typically 3 gram. Now remove everything, completely fill the pycnometer with water. Close the lid, that will be W4 gram. Calculate specific rate of water using the formula G equal to W2 minus W1 divided by W3 minus W4. What are the calculations required in computing specific gravity of pycnometer method? Calculations of tabular column, weight of pycnometer water, that will be W1 gram, weight of pycnometer plus soil, dry soil, W2 gram, weight of pycnometer plus soil plus water, W3 gram, weight of pycnometer plus water, W4 gram. Specific gravity G equal to G1 plus G2 plus G3 divided by 3. So your G equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. Validation or the value of specific gravity for existing soil falls in the range of 2.6 to 2.75. If there any variation is there, check under the specification provided and run the experiments to get accurate results. So the conclusion is the experiment is conducted as per the procedure laid down. The specific gravity of soil solid obtained is this value falls in the range of 2.6 to 2.75, and the type of soil is, so you can classify the soil depending upon the specific gravity or obtained. So how you can classify, it is given here. For example, if the specific gravity is in the range of 2.6 to 2.8, you call it as inorganic soils. If the specific gravity is in the range 2.753, you call it as tropical iron rich lateral. If the specific gravity is in the range of 2.65 to 2.67, then it is called as sand particle. If the specific gravity is in the range of 2.7 to 2.8, then it's called as inorganic clays. If the specific gravity is in the range below 2.6 and 2, then it is called as soils with organic matter. So what are the post-bio questions? What are the standard values of specific gravity? Just now we have seen the specific standard values of specific gravity of different soils types of soil. Do we need to conduct this test? Why? Yes, we need to conduct this test in order to determine the specific gravity of soil and also compare the soil with respect to water and compare its properties with water, and also to classify the type of soil. Before constructing any buildings, dams, we need to identify the type of soil. So specific gravity test is very important. Next, what is your interference on the result option? Yes, interference is a different test. Different test. What is your interference on the result obtained? The results obtained are of different values. What is the interference? The results obtained are almost same. Can we use them as also? Yes. Clear diagram is under. Next experiment is, it is also determination of specific gravity of soil solids by density model methods. So different method. This sort of one method is also different method. To determine determination of specific gravity of soil solids by density bottle method. So to determine the specific gravity of soil solid by density model method, specific gravity G is defined as ratio of weight of. I hope it is visible to you. I will just share the screen once again. To determine the specific gravity of soil solids by density bottle method. So how you are defining specific gravity G? is defined as ratio of weight of an equal volume of distilled water at the temperature, both weights taken in air. So how you are defining specific gravity? Weight of soil in water to the same weight of soil in air. The ratio of weight of equal volume of distilled water at the temperature. So specification IS 2720 Part 3 1980 is the standard recommendation to determine specific gravity of fine grained soil. So which code is used for determining specific gravity of soil solids? IS 2720 Part 3 1980 is the standard recommendation to determine specific gravity of fine grained soil. The value ranges are same as the previous experiment. The average of the values obtained shall be taken as specific gravity of the soil particle and shall be reported to the nearest zero point 0.01 precision. If the two results differ by more than 0.03, the results shall be repeated. So which code is used for determining specific gravity of soil? IS 2720 Part 3 1980 is the standard recommendation to determine specific gravity of fine grained soil. The value ranges are same as the previous experiment in the sense the specific gravity by pycnometer method, the values were given for standard soils. Same values here are same. The average of the values obtained shall be taken as the specific gravity of the soil particles and this shall be reported to the nearest point 0 precision. If the two results differ by more than 0.03, the test shall be repeated. So what are the equipments required? 50 ml capacity density bottle with stopper. So what is the first equipment required? 50 ml capacity density bottle. Density bottle you should use 50 ml capacity density bottle with stopper. Next, a constant temperature water bath. Second is a constant temperature water bath is to next open with a range of 105 to 110 degrees Celsius. Next, vacuum desiccators, vacuum pump, other accessories such as weighing bands equivalent to 0.01 gram, trays, wooden mallet, etc. So different equipments are required in this test, specific gravity test compared to your pycnometer test. More apparatus are required. In that case, only pycnometer was needed. Here, 50 ml capacity density bottle with stopper, a constant temperature water bath, oven with a range of 105 to 110 degrees Celsius, vacuum desiccators, vacuum pipe, other accessories such as weighing balance equivalent to 0.001 gram, trays, wooden mallet, etc. So the specific gravity of soil solids is defined as weight of soil solids to the weight of equal volume of water. So how we are defining specific gravity? Specific gravity of soil solids is defined as weight of soil solids to the weight of equal volume of water. So what is the specific gravity of soil? Calculated G equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So formula is also so देखो W1 is weight of empty bottle. W2 is weight of bottle plus dry soil. Next, weight of bottle plus soil plus water. W4 is weight of bottle plus water. This method is normally used for fine grain soil. The method may also be used for medium and coarse grain soil. If the coarse grains are passed through 4.7 ISO before using. See here, earlier method was suitable for both fine and coarse grain soil. But this method is more suitable for fine grain soil. However, it can be used for coarse grain soil if it is passing to 4.75 MSJ. So precautions what you need to take. Soil grains whose specific gravity is to determine should be completely dry. If on drying lumps are found, they should be broken into original soil. Inaccuracies in weighing and failure to completely eliminate the entrapment are the main sources of error. Both should be avoided. While cleaning the density bottle, please be careful as there may be glass grains projecting on material desking. Make sure you handle the liquid without falling on the legs. Hence, handle the equipment with care. These are the precautions. Now, procedure. Clean and dry the Renzi bottle and weigh it along with stopper. That will be W1 gram. Similar to your previous experiment, here also what you have to do, weight of empty density bottle with stopper. In that case, you took 30 gram of soil, here we are taking 25 gram of soil. Select about 25 gram of dry soil, free of clots and put the same empty density bottle. Weigh it with brass cap and washer, that will be W2 gram. Same procedure we are following here also, but the difference is there it was pycnometer, here it is a density bottle, and there it was a conical cup, here it is a stopper. Next, fill the density bottle with the add water up to half of its height and stir it, mix with the glass rod and more water and stir it, place the stone on the table. So that this third step is also same. We are adding half of the density bottle with water, half is your soil, completely filling up to the top, weighing with its stopper, that will be W3 gram. After that, remove all the contents from the density bottle, clean it thoroughly and fill it with distilled water. That will be W4 gram. Now repeat the process for additional time. See here, the experiment is almost the same. Whatever you have done for pycnometer test, same we are following for density bottle method also. Pre-viva question. Which method is accurate in determining specific variety of soil solid? Both the methods are accurate, but I will go with pycnometer method. What are the steps involved in determining specific gravity using density motor method? So steps just we have seen. First is empty weight of density bottle with stopper, that will be W1 gram. Next 25 gram of soil, dry soil free from lumps, and it's weight with stopper and washer, that will be W2 gram. Next you have to fill the soil and fill the density bottle with water, half filled, half soil with the washer and stopper, that will be W3 gram. Remove everything, add distilled water. Again, with stopper, that will be W4 gram. After that, G specific gravity is W2 minus W1 divided by W2 minus W1 minus W3 minus W4. What is the specification required? How much grams of soil needed? 25 gram of soil is needed. What are the specification you used? IS 2720 part 3 1980. What is the equation determines specific gravity? W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So this is the tabular column. Weight of density bottle W1 gram. Weight of bottle plus dry soil W2 gram. Weight of bottle plus soil plus water W3 gram. Weight of bottle plus water W4. Specific gravity G. So average G is G equal to G1 plus G2 by G3. Specimen calculation G is equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So test results are average G equal to the value of specific gravity for the existing soil falls in the range of 2.6 to 2.75. If there is any variation, check under the specification provided to the experiment. So the conclusion is the experiment is conducted as per the question later. The values fall in the range of 2.6 to 2.7. This type of class event. So can we use kerosene instead of water? No. Could we do classification? Yes. Could they enter? Yes. What are the various sources? Differences. What are the applications universe is used? For in order to calculate water content, liquid limit, plastic limit, specificity can be used. So in the next class, we will study determination of water content by soil soluble whole drying method. So I hope you have understood the concept. If you have any doubt, you can just drop him a message in the comment box. You can call me at 8553101858. You can even mail me at ultimate.gfund.university. So I'm ending the meeting. Have a nice day, friends.